Happy Thursday, Dr. Barth.
Hey, Eric, how are you?
Welcome to Roboduck Engineering. Tonight we're going to do lambdas for our Lisp interpreter that we have built from scratch in Rust over the last 3 weeks.
We've banged the rocks together. It is now time for functional rocks.
Yeah, something like that. It's actually remarkable how straightforward and simple Lisp is, as I've been learning Lisp through this exercise.
I mean, that's sort of its selling point, is that the core of it is really simple, and then you like layer all this stuff on inside the language as opposed to inside your compiler. And then you can drag your compiler around with you on your back because it's tiny.
Yeah, so anything to hit before we go to the code machine?
No, let's dive into it. I did a couple things in the Easy Bake Oven, which I'm excited to share.
Okay, let's share your Easy Bake Oven. All right, what'd you do? What'd you do, Doctor?
I added a test framework because I was tired of running these unit tests by hand.
So these are they?
These are they. So this is a test format that I stole from the HTML5 parser test suite. And then I forgot exactly how they did it. So I think I did it slightly differently. But the idea is you mark the input and say, okay, starting here, there's going to be some input. Then you give the input. Then you say, okay, starting here, there's the output. And here's what I expect that to evaluate to. And then this thing says, go on to the next test case.
Yep.
So like the simplest test case here is quote A should evaluate to A. And quote AB should evaluate to AB.
And I think we talked about I think the original HTML5 test doesn't have these markers. They just mark it with like when you hit a pound input, it like starts a new test.
Oh, I mean, that's totally logical too. I don't know why. But it was neat because then I can capture, like if you look down here, I can capture like errors.
I can follow you.
I'm just going to go, here. So like,
yeah, exactly. Just like HTML too, yeah.
Yeah, you try to take the car of a symbol. It's like, you can't do that. That's a type error. So, it just makes it much easier to bang out tests. And so since you end up writing tons of tests.
Yep. William says hi. Howdy.
Hey, William. Thanks for coming.
Okay, cool. So I see you wrote a whole bunch of tests, which is great. And tonight we're gonna add functions.
Yeah. So should we like test-driven development? Should we start?
Sure.
Write a test.
Make a new test suite here, or
it scans the test directory, so it's like super easy. You don't even have to do anything. So like, what's a good test? Lambda x car x.
And so
cons a x.
So this is just creating the function. We're not assigning it to anything.
Right. So now let's call the function. Let's call it on B. Okay.
And cons smushes two things together. So this should be AB, quote AB.
Well, it's just going to be AB because it's going to evaluate. Yeah.
All right.
Oh, how many equal signs do I need?
Yeah.
That's the downside of having
the danger of this format.
Try that. And then should we do... Oh, we start with that. Should we just start with that?
Yeah.
I think we can make that work. That's, half the battle, or at least maybe 90% of the battle.
Okay. So I suspect we must have keywords. I haven't looked at this code in a week, so I don't. We must have keywords here.
Well, I would try running the test and seeing that it fails.
Oh, okay, sure.
Yep.
Failed. Backtrace. Oh my goodness. Test failed. Okay, let's see. Left error. Not found lambda. All right.
Okay. Didn't find lambda. Agreed.
Okay. Cool. All right. Well, so we can go fix that. That's presumably in mod.
Right. So we have these. It's actually an eval. I think where we should try to fix it.
Okay. Yeah. So we're gonna need.
If you go to line like 35.
I'm just gonna follow you. Yeah.
Okay. Yeah. So here we bind these native functions.
Yep.
So we can't just bind a native function for lambda, because the way functions work is they evaluate all their arguments. And so we're going to have to bind a different thing, which in Lisp is called a special form.
Well, so to go back and just make sure, so that's because if this was a normal function, this would get evaluated.
Correct. It's just a value. Like instead of treating it as a parameter list, it would just be evaluated, and you'd immediately get X. I don't know what that is.
Yeah. And similarly, this would get evaluated, and it would have the same error of like I don't know what X is.
Correct.
Okay. And so instead, these basically quoted for you statements. These things are basically quoted once for you.
Yeah, so we could do a version where lambda was a function, where we manually quoted both the parameter list and the body, and that would work fine. But the way Lisp is typically done, lambda is a special form that knows that it's not supposed to evaluate its arguments.
Are there other special forms in Lisp?
So I think they try to go for a minimalism on that. So definitely, so I think like usually you have like if as a special form, because you don't like if takes a condition and then like a then and an else block, and you don't want to evaluate both the then block and the else block. You only want to evaluate the one based on the condition. And then usually there are a few others like the macro definition one, and then the question is like, do you build in other things? Like is define built in, or is define a macro? Like I think different styles of lists will do more in language, but roughly those are enough to get going.
So is there a reason why we wouldn't just write this as a function that quotes?
You could. I think
you can't. Right? Because wouldn't it already evaluate before the function is ever called?
Well, I mean, it just means like every time you wanted to write this, you would have to write that instead.
Oh yeah, no. We definitely don't want that.
And that's annoying. It's not how this works.
Yeah, no. So okay,
it's conceptually what's happening.
Yeah, but we need a special form. All right, so that's eval. So we need a new concept that's not bind native function, but rather bind special form.
Sure.
Okay.
Do quote. Copilot knows it. So that's another good special form is quote. Quote is a special form because obviously if quote evaluated its arguments, it couldn't quote it.
But we implemented quote differently, or quote, you can also just write out the thing quote.
You can also just write out quote. Yeah. So let's see how it goes with lambda. Yeah, see, it knows that lambda is a thing that takes 2 arguments. Copilot's amazing. It just knows things.
Okay.
So we can try to like implement them. Like
sure.
Let's see if Copilot knows how to implement them. Yep, that's how quote should go. It takes its 0th argument and just returns it without evaluating it.
Don't we already have quote implemented?
We have quote. Oh, we might. No, I think we did it as a.
Oh, we just did it right here.
Yeah, we built it in there.
Okay. All right, so we're going to need to.
I was going to see if Copilot knows.
We need to write a quote test. What?
Oh, okay. Yeah, let's write a quote test. Well, we also you want to do that instead of doing. Let's start there. That's good.
Well, we should test everything we add, right?
Okay. Let's write a quote test.
All right. So we're doing input, and we're definitely going to have to remove the exactly how many was this 6, 9, 10. Okay. I was going to say earlier, not to pick on you about that. Like, this is just how you do things, right? You gotta do things. You gotta be wrong in order to like learn that you don't want it.
Well, the key is you have to be willing to change it afterwards. Like once you realize that it was a bad idea to type 10 equal signs and make it exactly 10 equal signs, you have to be willing to say, okay, fine. We're just going to go run a script over our test to take these silly equal signs out and change our test parser. So we could do that, but it's a little bit of a distraction from this
we can do that in Easy Bake Oven. Okay, so quote A, B should output A, B, right?
You don't need the quote here because it's going to evaluate. This is the evaluated output. Yeah. And then you need my silly equal signs.
Oh, because you have to end it. Okay.
It's a terrible syntax, but it works.
Hey, it's great. It solved the problem. That was the important thing. Okay, that's the other thing about an MVP. It just has to solve the problem.
Okay, so now we need to actually make a special form. So we're doing it my way, which is top down.
Okay, that's great.
So arity function, right? I want to bind function from.
Do we need arity? We aren't enforcing it in other places. or are we?
Yeah, it enforces the arity.
Oh, it does. Oh, okay.
So what is func?
Adam and I have also been working on a second language in the Easy Bake Oven, and so my mind is slightly confused by this source space versus that source space.
Yeah, if you go to the Rubber Duck Engineering GitHub, you might find a second programming language that's mysteriously being created in the Easy Bake Oven. But maybe we'll talk about that on a future show.
Yeah, yeah. So in that other one we do not enforce arity, but it appears in this one we do. So that's good. Go us. Maybe Copilot helped us with that.
So I think we need to create a thing like func. So I think the thing I just typed there is wrong. We don't want to create a function. We want to create a special form. And we want to say from native.
Okay. Sounds like a plan.
So,
yeah.
So let's see. After a function, let's create a new thing, which is a pub struct special form.
Okay. Yep. Which is basically the same as function.
It's basically the same as function, but it just has a different type. And right now it's only native. At some point when we do macros, we'll probably, I don't know whether we'll do a separate macro class or not.
Because macros are just special forms.
That's a good question. I don't know. Probably.
Lisp is really remarkable for its simplicity.
I don't actually know that much about, like, I haven't really programmed a ton in Lisp. This is mostly, like, this is my mode of learning about something.
Mm-hmm.
To implement it. Okay. This is what Copilot.
Oh, I was thinking about that again this week. You're talking about mode of learning. You know, they say the was it learn one, do one, teach one, or something like that to really cement things in your brain. And I do this mentorship thing, and I was talking with one of my mentees this week. We were talking about recursion, and I feel like I've learned so much about recursion as a part of finally having to teach it to someone.
Yeah, you never really understand something until you teach it. That's really true. Okay, so this is what Copilot thought the answer was. Which is not quite right. Close, but not quite right.
Because we don't want to value function here.
But yeah, we don't want to make a function. Right, it detected that we didn't have a complete understanding of things. We need another kind of value called special form.
All right, well, that's easy to do.
And it's mad about this. Oh, equals.
I'm adding special form for you here. Okay, done.
Okay.
I'll come chase after you. I see Control Alt F. That's clearly what I need. Control Alt F. Here we go.
Alt F.
Yeah, that's how you follow somebody.
Oh, I feel followed. Okay, so everything is great. So where's our next error? So print value needs to know about special forms. Form. Where's our next error? Now we can just chase the errors and everything will work.
Okay. Well, we haven't actually implemented it yet, but yeah.
We implemented quote, right?
Oh, okay. I see. True. And we can just see if that works.
Right. So here, right. So we need to add special form here. Value special form. Okay. But importantly here, when to do check for special form. See, we left ourselves a breadcrumb. So we don't want to evaluate the arguments.
Mm-hmm.
So we took the args. We want to evaluate the first argument to see what it is. And if it's a special form, then we'll deal with that here.
We want to evaluate the first argument?
Yeah. So we need to split the args. Like, so there's the, there's that.
And that works because strings just evaluate to strings? Like is that evaluating the first argument, does that mean that is the same?
No, right, because that'll return the symbol quote. We need quote to be looked up in the environment to find the binding.
Ah,
Yeah.
Why does it do a lookup there? Because it's the first argument?
It just evaluates, the rules it evaluates the first argument. Speaking of simplicity, is anyone familiar with Jonathan A. Rees's W7 security kernel? It's an independent rediscovery of object capabilities in Scheme. Oh, cool. No, I had never heard of that. But yeah, there's a big connection between object capabilities and kernels and Lisp. It's all related.
Today I learned.
So I don't know if the thing we've done here is actually the Lispy way. So we've taken the special form and we made it first class. We've made it like a type, a value type. And I don't actually know whether normal Lisp does that or whether Lisp special cases it. But I don't think there's any reason not to just make it first class.
What would it mean to special case it?
So here we would basically look at the first value, the first entry in the cell, and if it was a symbol whose value was
It was a keyword, basically.
Yeah, we would go do something special. And we could test the Lisp implementation to see if that's how they do it. But in this way, it just becomes more normal. Like it just becomes a symbol lookup like any other symbol lookup. And so you could shadow it or do anything else you could do to it.
I see. Because this way you could do things like, I don't know how you assign variables in Lisp, but you could
just make functions for them, right? You can make like a function called like lambda quote. And you could call quote. Yeah. This would then quote would then just act like a normal any old variable.
Interesting. Which maybe not what you want, but yeah.
Yeah, I don't know what the normal way of doing it, but well, that's fine. We can do it this way.
Okay.
So let's deref this. Right. So one case is function, the other case is special form.
Well, we already evaluated them all. We're gonna have to hoist this.
We'll fix that.
Yeah.
So let's put that in here. Oops. Oh yeah, you're gonna do that. Great. But we want to skip the first one, like next.
Oh, what is this? Match op deref call.
Okay. We don't have to call. We just pass args.
Copilot trying to help here.
Yeah. It's mad about collect. I think we may have to put the type here.
No, this is the same one. I think you may have to. I feel like we've had this before. Is this?
Oh no! I messed it up. Next is not the right thing here. We want to skip one. It's called skip one.
Okay.
There we go. Special form dot body dot. What did we call it? What was the? When we define special form, where do we put the function? Oh, it's in a thing called body.
Yeah, it's identical to function. We made it identical.
Oh, okay. So we could use call then, right? I'm lost here. We could say.
You're right there.
Not a function. This is just op. Call. I think we don't have call yet.
All right. This is.
Yeah, we need call.
Chasing you is.
Call.
Mismatch types. Oh, we never returned the scope?
Oh, I probably deleted it. Okay. Should we see if quote works?
Sure. Perfect test. Error. Eval error, not a function. Not found error. B.
Okay. What did we? Well, first of all, let's take away lambda test, just so it doesn't confuse us. I'm just going to move it to the parent directory.
Sure.
Okay.
Okay.
Quote A.
Okay.
So what do we do wrong here? Should we debug it in some way? Evaluate it.
These are less debuggable.
Well, why don't we set a breakpoint inside quoted? Like inside quote, and we'll see if we get called.
I think we're dying. So this is eval error, not a function, which I remember seeing in.
Yeah, it's trying to evaluate our A and B.
But why?
I don't know.
All right, so you want to.
Yeah, just debug the golden test. I'm not allowed to run it. You have to actually run it.
Okay.
You go to
Where do you want
main
the error? Or you want it here?
No, I put a breakpoint in the function quote.
All right, and I think our tests are in mod here. No. Where are our tests?
The tests are in main.
Main.
Yeah, there's a test called golden test, which runs all the golden tests.
Okay, I think I have to run the whole thing.
Okay. Activating extensions. Whoa.
Rust panic. Maybe I just like never got the debugger working?
Oh, did we have a problem with the debugger last time?
I feel like we did. We had weird technical. Wasn't last time the time where like
the analyzer totally
flipped out for half the time?
Refused to tell us any problems with our code, and so we were just like helpless, like fish lying on the side of the ocean. Yeah. You're like, I can't swim. Where are my errors?
Oh my goodness.
All right, maybe the debugger was too optimistic. But let's just see if quote is being called. Like just say print line quote.
Okay. We could also
debugging.
We could also try this in our interpreter, right? We could try.
It's also likely that yeah, that's right. That looks good.
Isn't that just what we did?
Yeah.
So what's wrong?
Mm-hmm.
Confusatory. Okay, let's cargo test.
Test failed, basic.txt.
Golden has panicked that assertion failed, left equals. And the left, is the left what it should be?
Not a function A. I wonder if it's a different test case that's failing.
I agree. I see. Expected is not found error B. So maybe it's like this. All right, let's see. Hold on. What's this thing? Like.
That's the one that's the problem.
Like this could be it. What does it say the problem is? Eval error, not a function A. Yeah.
We were evaluating A twice. Oh, we evaluated. Oh yeah, we just changed the error. Right. The problem is not that. Yeah. That's correct. We changed the error, right? We decided to evaluate A, and then we checked whether the first thing we did was we checked whether it was a function.
Right, so it's just that we had fixed.
Yeah.
Okay, great. This is another thing I remember from writing the HTML parser.
Is this an episode on calculus? Lambda calculus. There's a lambda calculus. Defining first-class functions, at least. Yes, close to that.
Calculus was like 30 years ago, man. Not quite, 25. That was a long time ago.
Oh, there's another failure?
Arity error. It's supposed to be A.B.
What is the test case?
Well, that's what I'm looking for A.B. Maybe it's this thing. Let's see what it says. Test failed. Cons. Oh, I see. It lists the test right here. Cons A, B.
Yeah. That's the first one.
Okay.
Arity error. Okay. So why is this an arity error? I would expect cons to take two things, and that looks legit. So maybe we messed something up. Oh. Maybe we're supposed to
skip or whatever.
Let's see how the arity check is done in value. So this is in regular function. There's an arity check, which is
right here.
Right.
The link to args.
Yeah. So we've messed up in our argument evaluation. We're passing in too many or too few arguments.
Well, we changed it to skip one.
We did.
I don't know why you did that. It was previously next or something like that.
I mean, I think it may be just easier. I don't really trust skip. We can just do that.
We can also have arity error tell us a little more.
Oh no! Here's the problem. The problem is here on this line.
Okay.
We are slicing out. We're slicing out from evaluated. So
instead of just passing it.
Instead of just passing it. I'm going to change this back to skip because skip seems more like more legit here.
If we trust it, it's more legit.
We've got okay. The tests are catching real bugs.
Yeah. Okay. Test failed.
Oh, we don't have the skip. We somehow the skip got edited out. Okay, try now.
It's time with feeling.
Nailed it. Commit.
Okay, commit.
Test pass. Commit.
What do we got?
So we implemented quote, which is half the battle for lambda.
Yeah.
I'm actually excited that the I don't know, we only have whatever it is, a couple dozen tests, and it was catching real bugs. We were passing the wrong number of arguments to things. Right test find bug.
Hey. What is this? RDE number 113, I think?
Something like that.
Sounds good. Okay.
So now we put the lambda test case back.
Okay.
And we're going to fail that one. But now we can make a lambda special form.
All right. Failing the test. What do we got? Not found error. Lambda. Great.
Okay. So lambda's going to be a little bit trickier than quote. But it was a place to start.
Well, it gave us the concept of a special form. So that's something. This is another thing that I talk about sometimes with mentees is the importance of just notching a win. Just get to a commit, get to some small little thing so that your brain can stop thinking about that other one. At least for me, that's important. I just do not have space in my little noggin.
So the tricky thing that Lambda does, it creates a new scope and creates a scope chain. So we need to add the ability to have a scope chain.
Oh.
Right? Because when
it's like a closure?
It is like a closure, exactly. So it remembers the scope in which it was created. And then when you pass the parameters, that means it creates a new scope to contain the actual values of the parameters.
Okay. Okay.
Actually, we don't need the scope. We just need to remember the scope right now. We'll get there. So, okay. So we need a new... Okay, so over in values, we have function.
Oh, I started and stopped following you again.
Yeah, so we have native function here. So now we need to create a lambda kind of function.
Oh my goodness.
Hold a lambda. Okay. I'm over in...
That's fine. I'm coming. Okay, there we go. Func
we had a native function. Now we need to create a lambda function.
Okay.
What is a lambda? It's a struct that contains
scopes and args.
body, its value.
Okay.
Yeah, it has to have a scope, which is its scope. So I guess scope is going to have to become an arc because we're going to have to keep a reference to it.
Okay.
And then it has its formals. Its formals, which is a vector of strings. Or I guess a vector of symbols. What is a symbol?
Do we have symbols?
Symbols a string, yeah.
Okay.
Okay, this is a pub struct. It's going to need like all these exciting attributes on it. Well, why is it mad? This is a struct.
Syntax error. Yeah.
Okay.
When it's 47 errors, it's often a syntax error. Okay.
Okay, so this is what Copilot thinks the answer is. Copilot thinks it takes this, which looks pretty decent.
Mm-hmm.
Function lambda. No, this is a function. Func. Func body lambda. Pretty close.
Mm-hmm.
Okay. Oh, this takes a func whose lambda is a lambda. No. Okay, we actually Copilot's not smart enough to write it. We have to write it ourselves.
Okay.
Name. We don't know what the name is. Name, I guess we'll just call it lambda.
Okay.
Okay. Its arity is formal, the length of the formals.
Yep.
And its body is this thing. Okay. That's good.
Okay. Yep.
And then how do you call lambda? You take, that's fine, but I'm going to do it a little differently than what they're doing. So we need to have so let's look at scope.
Mm-hmm.
Scope has a hash map of strings to values. So we need to create one of those hash maps. So we're going to say let values, what do we call it in scope? Values.
I think you're going to need helper functions on scopes here. You don't want to make a big one. Yeah, go ahead.
Hash map. Oh. Yes, that.
Hmm.
I want to pass in new child. Okay, and I'll pass in this, and I'll pass in my self scope clone. And then what I want to do is I ultimately want to eval the body. Scope comes first, apparently, on eval. Copilot's not quite right. But yeah, so we want to eval the body in the newly created scope. So we need to import hash map.
Mm-hmm.
So we're going to go back to that because that code was super subtle. So
William said, that's what makes this channel so fun. After scratching your head all week and going back to square one, making something and seeing it work feels really good.
It does.
I don't know what the context was, but yes. You're saying, sorry, I talked over you.
I was going to say, this is really subtle, but does this make sense to you, Eric?
Let me chase you. Okay. Call. This is call on lambda. We make our bindings. We take our formals and we zip them with our args. That makes sense, right? So we're just defining a new hash map that contains all of our definitions of names to argument values.
Mm-hmm.
And then we're making our own new scope
mm-hmm.
with those bindings, and this being the parent.
Yep.
Yeah, makes total sense.
And then we eval the body, whatever it is, inside that scope.
Mm-hmm.
So I think we need to implement new child on scope.
This feels... go back to new child. I think you want... I think you want that to be a... sorry, I lost you here. There we go. Yeah, I think you want this to be a I think, don't you want self.scope.new child?
Oh, sure. Yeah, that looks legit. This part's a little optimistic, but yeah, that's way more sensible way of doing it. Okay. Okay. We have a bunch of checks we need to cache, make good on.
Okay.
Environments are not mutable here. Ah, that's a really good point, William. Yeah, so normally in Lisp, environments are mutable. There's a thing called define, which will mutate your environment. But for simplicity, we're doing immutable environments just because it makes our lives easier.
That said, I've also just become an increasing fan of immutableness in programs.
Mutually recursive functions may not work if you copy the environment when you. Yep, you're exactly right.
Mm-hmm.
Gold star. So in the other programming language that you'll find on GitHub, you'll see that we attempted to do what's called let recursive, which allows you to define, basically create some bindings and then define functions that could then see each other's bindings and so be mutually recursive. And we failed for exactly this reason. You got us. But we're okay. So now I'll give you another piece of philosophy about why we're right. So the reason we're right is we're doing it the easy way. And later on, when we go to implement recursive let, we'll have to go refactor and make that possible, probably by introducing a mutex somewhere or some way of recovering mutability in a rusty way.
All right, so that we have to implement. Scope does not implement debug. Fine.
The other big change we did is now scope needs to have we need to use arc scope all the time instead of regular scope because we have lots of people are keeping references to scopes.
Okay, it wants partial equal and equal for scope. Does that make sense?
Sure, why not?
Okay, and when we need to.
So now we just got to fix all of our errors and lambda will work.
Working on it. Scope. I want new child. Yep. Scope findings. Oh no, this is not
arc scope.
Oh yeah. Okay.
This needs to return arc scope. So arcs. More arcs. Okay.
More arcs. Stop arcs.
Arc. More arcs. What's wrong with this? Hash map. String.
I was just getting that. Yep. Okay. New child. And then this is going to be, except this needs to be findings.
Yep. We need to change how lookup works, by the way. So if
we need to keep going.
Yeah, we need to say else if let some parent equals self.parent, then look up in parent. Otherwise, unknown.
Yep. Good old recursion.
Like we should really do this iteratively, but the recursive way is just easier for now. Oh, arc.
Okay.
More arcs.
Works.
Okay, we have 4 errors.
Mismatch type expected, arc, scope, and we got a reference. The new.
Oh, we need to do this. So we need the arc version ourselves, which is fine.
Yeah, there's like a few of those that the compiler understands, arc being one of them.
Yeah, that is like a super magical part of Rust to me. I don't understand, like, can you create your own type for which you can do that? Or like, how does that all work?
When I read about this a year ago, you couldn't. And it was just the like few magical.
Yeah, Rust is so elegant, except for like, that seems a little magical. New child. What's wrong?
Someone who actually knows Rust and is watching is going to tell me that I'm wrong. So, but that's what I recall. Mismatch types, expected struct, found struct.
Okay, this was too clever. Like, let's put a map here. We need to do something with this.
What's too clever about it?
We need to.
Oh, clone them?
We need to clone them or something.
Closure expects to take a single tuple as argument. It's two distinct arguments. Okay.
Yeah.
Name iter found for struct zip. I don't know why a zip is too magical. Maybe it's like into iter?
Why is map mad?
Why are you mad, Map?
Why are you mad, Map?
Closure is expected to take a single two type. Yeah. Okay, more parentheses.
More parentheses. Call. Oh, this is a good one. Yep. So now we just need to implement the lambda version of call, which is lambda call. Okay, problem solved.
As you would say, nailed it. Okay. Struct, found reference, arc. What?
What is ours? Oh, this is a slice. We got the wrong type here. This is the correct type.
Oh, for the.
Yeah, Copilot wanted a vec. Copilot was not smart. Okay, we'll fix Copilot's junior coding mistakes.
Okay,
like
so now we
junior engineer.
Now we just have to implement lambda.
Oh yeah, but that's no problem, right?
A junior engineer who instantly gives you a drive-by, insert for your program. That's not how junior engineers work at all.
This is what Copilot thinks the answer is.
Okay, lambda.
No, this is not right.
Okay.
Okay, params is 0. If it's a cell, no, we have fancier stuff than this. It's good try, Copilot, but two args.
Arg0 is that?
2 args. Yeah, the 0th argument we want to create to a list.
Okay.
Now this is a vec. Yeah.
Arc new data value lambda.
This is close. Yeah, this is all
Isn't
good.
Lambda function? Isn't that its value func, right?
Yeah, valued function whose
func body.
We just need a way of creating a new function. Func new, yeah. Oh, name. Didn't we do this already? Did we say?
There's a func new. I see it right there.
We have lambda new. That's what we want to do. Lambda new returns an arc value. So we just need to call it lambda new.
Okay.
All this can just go away and become lambda new. We wrote this function already. Lambda new.
Okay.
But the params are not quite right. We need to map the params. So we're getting a value, and we want to get out a string. We need to.
And these are really formals.
Okay. They're really formals. Yep.
So
want to match the value. Match the value, and if it's a value symbol, then great. Get the string out. Otherwise, we want to get an error, which is a type error.
Yep.
Okay. And map is mad. We need to iter. Okay, more iters. And we need to collect at the end.
Oh, yeah.
And then we need to actually specify that we want this to be a of strings. That's what they're collected to. Okay.
Okay, symbol. Okay, yeah.
as ref or as refs. Okay. Cannot infer type. This cannot.
This specific thing of collecting a list that could be result, like I feel like we looked this up several times.
Yeah, this is like the bane of my existence. This thing returns.
There's just a pattern we haven't learned here.
Yeah, there's something missing in our understanding of this magical. Because what's happening is this iterator is returning a. It's returning a iterator of result.
Yeah.
And then collect is doing this magic inversion where that makes it a result of a vector. Yep. And its hinting is not quite there.
But that's also throwing away data too when it's a vec of results. Collect result vec, I think, says James R.
Yeah, there's something like that. Yes.
We looked this up on Stack Overflow multiple times.
James, how you doing? Thanks for coming to the show.
Type annotations needed. Don't make me go look it up on Stack Overflow again.
Okay, we're gonna do what James tells us. Hi. Okay, we're gonna do it the James R way. James R is always right.
I like that James R has the duck. As well.
Okay.
Perfectly set up the show here.
How to do it? He said, okay, with turbofish operator, and then we'd say result vec, result vec underscore, because we don't know a vec of what, and we don't know what the error is. We know what the error is. The error is error.
We've hit a new level of the show where participants are talking to each other. Not quite Twitch chat, spamming dancing parrots, but
okay, great. So now we have the real errors. Good. So let's put in lambda as our special form. And I made a sneaky change, which is I now changed what the signature for bind special form is to take a scope, because we need a scope. Now. Yep. And then special form from native, we also need to change this to include an arc scope. Okay. And then we should have a type def for this instead of typing this a million times. Come this far.
Okay. Oh, special form func, just like you did for func body here.
Yeah. Okay, I can't take it. We got to make a type def for it.
Expected function pointer. All right. Where are you going?
I reached my limit of trying to fix up these things.
Well, if you just click over to func and func body, you did it here.
No, I just want to do type native special form equals this, except it hasn't learned that I wanted an arc environment, arc scope. Now every time I write this thing, I want to write this instead, and my life will be better.
Okay. Body, native, name, self, new.
Okay, call is fine. Native, that one's fine. That one is fine. Okay. Body, one I want to change. I want to change. I don't have to change.
What's the difference between new and from native? String.
I expect we never call this one.
Stir.
Oh, one calls the other. One does the arc new value mumbo jumbo. Yeah, whatever.
Fine.
Arcs. Okay, so now when we call this, we actually need to take our scope, arc scope, and we need to pass it through here. Scope. Yep. And then
I don't know why it doesn't see native special form there, but
okay. And then here we need to pass in our scope.
Yep. Oh, it's our one error.
Oh, I need to make this public. That's why.
Oh, I see.
Let's make it public.
Okay.
One more. Unused variable. Oh, that's fine because quote doesn't actually care about scope. It's fine. All right. You think our test is going to pass? What does James say? With that syntax, I'm not sure what happens if there are multiple errors. I think it like the compiler yells at you and says, "I don't know what to do."
Oh no, I think it just picks the first one. Exactly what
it passed.
Yeah, it passed. We did lambda.
I don't believe it. We got to make a test that fails.
Okay.
Output.
You do have all of one test.
X. Let's see it fail.
Fails.
Okay. Fails. Yeah, so we did lambda. Unlike in the previous shows, in every show in this playlist, we have tried to do a thing and we have gotten like a little bit over time and not actually gotten it done. But in this episode, I am proud to say we actually did what we set out to do.
Just reviewing our change here. Implement lambda and nested scopes.
Oh, you guys spelled lambda right. The red squiggle is totally mad at you.
RDE number 113. Okay.
Should we do if?
What? What's that?
Should we do if?
To see if we can have something that fails right before we get there, or we can try if.
I think if
you mean like a second special form is what I think you're getting at, or a third special form.
I think if it's just like a hop, skip, and a jump from where we are.
Okay, let's try.
Let's try. So let's try
if function. You can't use a keyword, yeah. If fn.
Okay. So the args. So this is like let condition equals.
Oh, it hits variable arity, doesn't it?
No, it only has arity 3. Condition, let condition, let then case clause is the first thing, and the else clause.
Because you always have to provide a then or an else, rather.
Yeah. At least in our version. I don't know about real Lisp. We need to say we want to actually eval in this scope the first argument.
Mm-hmm.
Okay. Question mark. For the first argument. And then we should say if condition is truthy. Is that a thing?
I don't know.
It's really banging
for our value, yeah.
For us, we compare against nil.
Okay.
But we could. Why don't we implement is truthy? That's a good suggestion, Copilot. Copilot is writing better code than I am, so I can't have that.
I remember we did something similar in Ren. You want is.
Yep. It is truthy, and evaluate the then clause.
Yep.
I want to name this just for no particular reason to name it except for like it readability.
There you go. It's truthy if it is not nil. At least that's
register. Oh, you registered if it's a special form. Great. So let's write a test.
Oh, I see. Because you moved nil back into value. Oh, good.
Mm-hmm. Yep.
You did that in the easy bake oven. All right. All right. So
Okay.
a new file. Oh, you already did that. Fine. Great.
This test, so we get the right number of equal signs.
Yes, I was about to say.
So if a B
C.
C.
Mm-hmm.
I didn't quote C.
B.
Yeah. You know what? I'm going to not quote A and B. And what I want is error, like like a particular error. Well, no, that's not good. I'm going to quote.
Why would it give you an error?
This is what I
Because
wanted.
B evaluates to itself. It's a string.
No, these are symbols, right? So it's going to try to evaluate those symbols, and they're not going to be found. It's going to be. I mean, there are lots of tests we could write, but I think I want to write error not found C. Right.
Okay.
So basically, if false, then evaluate the else clause, which is going to blow up because it's not found.
Okay.
I don't know.
Sure, why not?
Why not?
All right. Let's see it.
Boom. So I don't trust it. So I always wanted to do a negative test.
Try another one here. 1, 2, 3.
Okay.
And this should do 2.
Well, if let's quote these A, B.
Why?
Numbers aren't a thing, right? We haven't implemented numbers, and when we come later to implement numbers, the test case will break. Optimistically, if we do numbers.
I see. Failed.
Why did it fail? What did it get?
Sorry, having trouble scrolling to the exact thing. Okay. Not found. 1.
Oh, 1 is not found. Oh, sure. Let's do our X.
Great.
Okay, well, we validated the tests are running. That's good. Pass.
Great.
Yeah, so we did if. So once you have all the machinery, like we just implemented if then else. Yeah. Like I think that's pretty cool. Like Lisp is cool. Like there's something interesting going on here.
Mm-hmm.
Like it's somehow it didn't take over the world, and I think it's an interesting question. Why didn't it take over the world? But it has some really neat ideas in it. Like you can sort of see the power being brought out by like how easy it was to just implement if then else. In a normal compiler, like let's say we were writing a Python compiler, we would have had to type a lot more stuff and do a lot more work to implement if then else.
Yeah. I don't know why it didn't take over the world. I mean, its syntax is pretty intimidating.
That's what Paul Graham thinks. Like if you read his essay about Paul Graham is a huge Lisp fan, as Eric knows. I'm just saying for the audience, but he has like an FAQ, like why is Lisp amazing? And you like, and one of the entries is like I want to use Lisp, but my boss won't let me. What should I do? And Paul Graham says something like, probably your boss is just intimidated by the syntax. Which I thought was amusing.
Well, that article, the FAQ is from like 2005 or something like that. And his response is just use Python. You're close enough, or something like that.
And it's true. A lot of these languages basically evolve. Like Lisp is this very attractive point in the design space. And so a lot of languages, as they evolve, grow sort of Lispy kinds of features. But there's something about the like simple design that I don't know. I find it very aesthetically appealing.
Well, we did all our homework in so little time. You want to tell the folks about pizza? Did you do pizza this week? Or I don't know what we do normally to close the show.
We did pizza this week, but we made a new dish this week that we never made before. Well, it's a Bengan Barta, which is an Indian dish. It's like a roasted eggplant dish. And we made it. What is that?
You and I have made Bengan Barta, so but go on.
I've never been happy with how we did it, but we did it a new way this time. Because what they always tell you is you're supposed to roast the eggplants on your stove, like directly in the flame.
Yeah.
We did that.
And?
It was amazingly delicious. It was smoky and silky. It was great. The only bad part is I work from home. And so my wife was cooking it on the stove, roasting this eggplant. And I was sitting in here, like one room away from the kitchen, smelling this beautifully roasted eggplant while I'm trying to have like the last couple of meetings of my day. It was torture, let me tell you.
Yeah. Well, it was wonderful as always. Thanks all for showing up. And I think we got maybe like one more Lisp episode in us. And then who knows what sort of adventures. So, any last words before we part?
No, see you all next week. Thanks for coming.
See you next week.